Hydrogen sulfide.
H2S.
By Diana Diaz, Wendy Flores, and Allison Hess. This is a rough draft of the drawing H2S, and in the model we could see a sulfur atom along with two hydrogen atoms that make an angle of 109.5 degrees, which can be seen through the protractor along with the molecule. As well as that, we labeled the atoms, and then we labeled the bond that it makes, which is nonpolar covalent bond, and we also added the name of the molecule, which is hydrogen sulfide. And then in the next in the next slide, we have the final drawing of H2S, and in this, the difference between this one and the last one is that this one includes the unshared pairs of electrons, which are basically lone pairs that the sulfur atom has, and these lone pairs are responsible for making the geometry for the molecule and the angle that it makes, which is 109.5 degrees.
The H2S molecule sketch. The molecule geometry is bent. Electron geometry is... Hold up. Am I supposed to read this too? The H2S molecule sketch. This is an example of how our molecule of H2S is in the PhET simulation. The model contains not only a sulfur atom and the hydrogen atoms, but also lone pairs. These are pairs of electrons that the sulfur atom is not sharing with the two hydrogen atoms. As a result, the hydrogen atoms are pushed together as the lone pairs take up space. So this is the 3D model we did. The model has two small white spheres that represent the two atoms of hydrogen. The yellow sphere is the sulfur atom in the molecule. The two white balloons are the unpaired electrons of H2S. The model is a correct illustration of the H2S molecule.
The materials that we use for our 3D we use foam balls, paint, white balloons, two bros, glue gun, scissors, pencil, and ruler. Evaluation 1. How are electrons used to predict the shape of the molecule? First of all, we can see that in our draft, the molecule that has two hydrogen atoms are close to one another. So, what creates them to be together in order to get the 109.5 angle? Furthermore, the atoms are being pushed closer together as these are pairs of electrons. According to our linked source, the VSEPR theory defines that the geometric shape of a molecule is determined by the repulsion between the electrons in the valence shell of the central atom. The angle of our molecule is 109.5. This is due to the repulsion between lone pairs and electrons on the sulfur atom. So, how are electrons used to predict the shape of the molecules? According to our source, the theory states that the force and repulsion between electrons determines the angle and shape of molecule. In our model, there are two lone pairs, and the lone pairs are used to predict the shape of the molecule.